So, are you ready, yeah? That's a good sign. Okay, headphones are going down. So, Marc Cluet I've known since 2010, I think. So, 15 years, longer, 2009. Yeah, which I think was actually the year of John Allspor's talk at Velocity. Can anyone remember what that was entitled? No? Come on, this is DevOps history, everyone should know this. No, sorry, I shouldn't shame the audience. 10 deploys a day at Flickr, I think it was. It's a big revolutionary thing back in the day. So yeah, that's as long as I've known Marc Cluet. None of us are getting any younger, so it's about time we both got on the stage more. So yeah, it gives me massive pleasure to bring Marc to the stage to talk about AI and DevOps and how to evolve sustainably. Give him a round of applause, please.
Yes. Thank you. Hello, everyone. You normally see me behind the camera, but now after a 5 years hiatus, I get back in front again. So, you people know me because of the London DevOps logo, right? So, I just started this with Matt Saunders back in 2014. Yeah. Because, to be honest, I did suck at speaking in public. I started speaking in public like I suck, I freeze, this is not great. And also, we were in DevOps very early on. So I took the chance and said, we need to get out more, we need to speak in public more to get used to it, right? So the best way to do something you fear is just repeat and repeat until you either die in terror or you actually get reasonably good at it. So besides that, I've been working in IT for 30 years. I've done every single technical role you can think of. I've done all of them. I racked modems in an ISP back in 1997. I was racking modems. In 2001, I decided to upgrade by racking modems inside water tanks in Iowa in the middle of winter. And that was an experience. I can tell you more about it later. I've done DevOps since it was called DevOps. I met John Allspor. I met all the creators of DevOps. I have been around for a long time, long enough that the DevOps Institute, who you may know from this thing called the DORA report, asked me to be one of their ambassadors, and I feel very lucky about it. And I'm also quite privileged to be an ambassador for Open UK, which is an organization that promotes open standards in the industry. And not only that, it also talks with the UK government. You will see photos, if you follow them, of Open UK at Westminster, talking with MPs and trying to make sure that free software is something that is protected by rights in this country. And I think that's something really important. So, enough about me. We're going to talk about AI, right? AI is a new thing, correct? No. Yeah, new thing? No? No. AI has been here for a really long time. Back in the 50s, Alan Turing, famous because of the movie, obviously not anything else, Alan Turing, creator of modern computing, he already created the Turing test, a way to try to understand or differentiate between human thinking and machine thinking. And we have been accelerating from there. It's been going on for quite some time. And as I said, AI has been here for a long, long time. I've been in 2 different AI startups. One of them, in 2014, it was one of those AI assistants that organize your calendar and then you had to stop it and reorganize your calendar again. But the other one was in 2003. So I was doing AI in 2003 when it was called AI, but it wasn't really AI, it was just statistics, lots of statistics and some thinking behind them. So, as I said, AI has gone through different evolutions through time. The first one that I think is worth mentioning is 20 years ago with machine learning, deep learning. You can still find books about these algorithms. They're really incredibly interesting. There's a lot of maths, and bad news, there's even lots of math in all the newer models, right? So there's a lot of maths, a lot of prediction. So all these models were based on high fidelity predictions. So when the predictions got around more or less 80% of chances, like, yeah, this is a very good chance that this will actually happen. So we're going to show this to the user. And that's how suddenly AI started to discover the things you liked, even the things you didn't think you liked. Because due to statistics and median calculations and all the rest, it got to the point where it more or less knew what you wanted and it showed it to you. But then, as I said, this also enabled NLP. So NLP is all based on machine learning because it's a very good way to predict or calculate and predict what you actually meant, which is what most humans, as me, that are bilingual do. I try to predict what people say because I normally don't understand half of it. But then, as I said, 2020, middle of the pandemic, OpenAI releases GPT-3, and this was an explosion, in a way, an evolution. It was based on large language models, which is a lot more of maths than machine learning, a lot more computing, and an incredible amount of data, right? So, and these agents that are based on LLM are capable of completing and understanding tasks in a certain area of knowledge. So you give them a lot of things in that area of knowledge, and they understand what they're doing, or they can give you limited answers on that based on all the training they have, which is a lot. So with GPT-3 and all the rest, LLM models just became bigger, better, more data, more predictions, more ways to do this, but this of course consumed a lot more computing. There's models like DeepSeek that are shortening that just because of that stupid embargo of chips with China. You know, there's not a war or anything. But there's ways to do this, but the majority of ways is just throw a lot of data, throw a lot of compute, throw a lot of money, a lot of power, and at the end of that, you get something that plays back at you something that knows very well what they're doing, or most of the time they know very well what they're doing. So this year, Agentic AI was launched, and Agentic AI, what it does, and the difference that it does is that it's LLMs talking to LLMs. So they all have a certain area of knowledge, the same way that you would have in a developer team, right? One guy is great at front end, one guy is back end, the DBA, etc. So all of them talk and try to resolve together through iteration a certain problem. And this is where we are right now. And in my opinion, this shows the evolution of this, and the speed that of the evolution of this is showing how AI will be a great accelerator, right? It won't go slower, it will go faster and faster and faster, and it's coming at incredible speed. And just to give you context, right? This is Garry Kasparov. He was the world chess champion, incredibly smart guy, incredibly smart chess player. IBM did this of trying to get him play against a machine learning thing called Deep Blue. Deep Blue played against Kasparov in 1996. He lost because, of course, Kasparov, chess champion, knows everything there is to know about chess, right? So the Deep Blue team went back to the drawing board, retrained their model. 1 year later, they defeated Garry Kasparov. It took them 1 year. There's this game called Go, and Go has millions and trillions more movements than chess, so almost infinite amount of moves. And 19 years later, this company called AlphaGo had the challenge to do the same with Go, and they did it. They beaten the Go champion of the world. So this tells you again, this is coming at speed, this is evolving really, really fast, right? And it's just going to go faster. We're just going to keep evolving faster on this. So now we go to the DevOps side, right? What is DevOps about? It's about the tools. It's about the stickers on laptops. Maybe, not really sure. But as someone really wise said, this is also my favorite definition of DevOps. DevOps is a culture. And it's a culture where people work together, right? And they create processes together, and they accelerate these processes using the right tools to create value, to create result, to go to market fast, right? So DevOps is all about people. It's people, it's always people, it's a culture. without people, there is no DevOps. Any company that says, buy one DevOps, is like, no, thank you, I already got the people. So, and I always say that. Any company that I go to is like people, process, and tools, always in that order, never the other way. Because a lot of companies buy a Jenkins, if they still buy Jenkins. They buy a Jenkins, they buy a Azure DevOps, and they say, oh no, we got the tool that does DevOps. It's like, yeah, but you cannot shape your team and your processes around the tool, because you will end up in a really painful place, right? So DevOps reinvented what it is to be an IT engineer. It reinvented what it is to be a sysadmin. I used to be a sysadmin. I was really more or less moderately happy to go to the data center with big headphones to mute all the noise, get my CD and install my service and do all the configuration and all the rest. I haven't done that in years. And this is partially because of DevOps, right? Because DevOps created acceleration, automation came after, and all of these got to the point where you don't have to go to data centers anymore to do these things. You can get all the companies to do that for you, like AWS, Microsoft, Google, etc., right? But it reinvented what it is to be an IT engineer. It reinvented what it is to be a developer. You have all the CI controls now, all the automatic checks, pipelines, etc. It accelerated a lot of that. So it reinvented our industry. So when I talk about DevOps and about DevOps transformations, I've done a lot of them in different companies, and some of them you might have heard of, some of them you might not have heard of. But I always tell to every single one of them, any transformation is like having a mixing board, right? And you have a mixing board and you have a rubber band connecting all these levers, right? And you buy the DevOps tool, the automation tool. You push that to 11. What happens? You have one of them pushed all the way to 11. You have created tension in all the other ones because they're not moving. There's tension there. If you accelerate one of them too fast, that tension will break the rubber band. And that in reality in your business, breaking the rubber band means people quitting, means your website is down, your business is down. There's something that has gone wrong, right? So you don't want to do that. And one of the main things is that any DevOps transformation, it's all about taking people on this transformation journey all together. And you slowly push everything up at the same time to reduce the friction, reduce the tension, and accelerate. Because that's what you want at the end. You want everything to 11 in a way that is sustainable. And there's one of the DevOps authors that I used to work with that he did a book that is called Sooner, Safer, Happier. And it's all about that, right? It's getting market sooner, but in a way that it's safer, and you are doing it happy, right? It's creating that value sustainably, without friction. So, does AI change any of these? Does AI change any of the friction, of the upskilling? No, it just creates more tension because you go faster. You accelerate the delivery, you accelerate the creation of code, you accelerate the tests. So you need to go faster, right? But all these principles, all these things, all these books about DevOps processes and team topologies and all the rest, they're still really 100% valid. So that's what AI is. AI is a workforce transformation and upskilling problem. Again, right? DevOps transformed and upskilled the engineering population in general in IT. AI will do the same again, just faster this time. It will create more friction. It will highlight all the handovers. It will highlight all the points, choke points. And all of that needs to be resolved at some point. So Gartner, and you know Gartner is famous for its Gartner Magic Quadrants, that all the vendors that try to sell you anything is like, we're on the quadrant and we're over here on the right side, we are amazing. Gartner is a company that spends a lot of money and there's a lot of brains making sure that they understand what is going to happen, making sure that they understand what is the next thing in the industry. And they have said this. They have said that every single engineering role will be fundamentally reshaped by AI by 2030. Every single one. So it's coming, right? The question then is how this is coming. So if you have been long enough in this and you have an interest in computing history, as I do, you will know who Dorothy Bourne is. So she has been portrayed in a movie about NASA and about computers, but it shows you the willingness to change and the willingness to adapt to times, right? So Dorothy Bourne is a really skilled woman, is a really skilled person. She was what it was called the human computers back at NASA in the 60s. A human computer was literally calculating every single thing that happens to a rocket, to a spaceship, and making sure that people could come back to Earth safe. That's a lot of math. And if you get it wrong, you might kill people. So you need to make sure that you're doing things right. So that's how NASA did all the first Saturn and all the first parts of the Apollo program with human computers. And then NASA, as they realized that this was a problem that they were just throwing more and more and more people at it, they then had IBM approach them. And IBM said, we have one of the first computers that can do this for you, and it will be way faster than all your human computers. And IBM came in, they used a gigantic room with a machine that would be less powerful than any of your phones right now. And they said a lot of men with white shirts, black ties were there, and the human computers were looking at it and were like, no, 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 this is way too complex for you. We'll deal with it. And Dorothy Bourne wasn't impressed by that. So what she did is that she went there, she grabbed one of the manuals, she started studying this thing called Fortran, and she literally became the first black American woman that was a computer engineer at NASA. Right? She saw the change, she saw that the change was happening, she adapted to it, she's history now. So we are again in that place, right? A lot of human computers, mathematicians at NASA were fearful of change, and they didn't want to change, and change happened anyway. So the world is changing, and change we must, right? The world is not the same as it was 10 years ago, 20 years ago, 30 years ago. We are going at speed, maybe not in the right direction for some people, but it's happening. So now, how AI and DevOps get along, right? So I think personally that there's a lot of synergy between both. There's a lot that DevOps can add to the AI revolution. And going back to this, I said, it's all about not creating tension, right? But now we have something that can turn levels to 11 in months instead of years. So we need to be mindful of that, and we need to adapt our processes for that. So let's talk about people, process, and tools again. So let's start with people. That's pretty much how people see AI right now, right? And you've seen this, right? It becomes something that you were spending some time coding something, and then you spend some time debugging, and you knew the code well, and it was all right. Now ChatGPT generates the code, and you spend 1 day or 2 or 3 going, why has it done this? It's like, I don't understand what has happened. This doesn't work. This is not great, right? So just going a bit back, right? If we go back, again, computing history, the first coders in the 60s and 70s were programming using transistors and soldering things together. The first ROMs on the first Apple computer, the boot PROM, was literally coded in the motherboard. The first programs were there. You didn't have anything to do to write it with. You just went, sold it away. You knew your ANDs, ORs, XORs, etc., and you created your program that way. Then, this got old really fast because, you know, having to smell soldering iron all day is not great. And then we, more or less at the same time, slightly just after, we invented punch cards. And punch cards was just a representation of machine code. And of course, they could go wrong. It's paper. Oh no, I have to debug this, blah, blah, blah. It doesn't work. I have to punch the whole card again. It's a pain. So we were there for quite some time, for around 10, 15 years. And then we went to machine language. So, and that was revolutionary because now you had a screen and you can start typing things into the computer, but you had to speak the machine language directly, right? And I've learned assembly. I've done assembly. It's really fun, but it forces you to think literally like the computer and how the computer will deal with things. And in the 70s, then we started creating what is called the high-level languages. So, for example, C is one of them. We still use C nowadays. There's other languages that we use less, like Fortran, COBOL, etc., etc. And we have Golang, we have the Pythons, and all the rest, right? But at the end of the day, all of these high-level languages get compiled into machine language that then gets executed by the computer. So we are just one abstraction layer above. We're just converting what we say. So in reality, what coders are doing is that they are interpreting human communication and requirements, converting that into deterministic code that the machine will understand, compile, and execute, right? And I think that we are literally going one level up. Not yet, but we're going one level up. We're going to speak to the computers using some kind of human language, because human language is non-deterministic by nature. I was asking myself the other day, if I have to create a website, how do I say which shade of blue I want? That's a nightmare, right? It's like, I want this blue, but it's slightly less blue than this one, but more than the other one. Yeah, good luck with that. So now the thing is, we are going one level up, right? We are creating this deterministic language, non-deterministic prompts that we feed into the AI, and they generate all these things. How about we treat these prompts as code? We do iterations, we do code reviews, we do linting, and we group all of these prompts to create a program. And this is what OpenAI suggested literally just 5 months ago. They created the OpenAI model spec. And a model spec is literally marked down in a Git repo. And this markdown is just all the different steps to create a program. You feed all of these to an LLM model, and it will write a full program for you with front-end, back-end, database connections, everything you need. Right? I would recommend, if you want to know more about why and how and written specs work, there's this amazing talk from Sean Grove from OpenAI that explains this, right? And I said, written specifications can be linted. You can check for ambiguous language. You can check for things that are a bit contradictory, because I said human language can be confusing sometimes. You can feed it to different models and get different outputs, and you can choose which model you want based on which output is the most optimal, right? Not only that, but there's, of course, as with everything, there's competition here. There's a company called Tessel, which is here in London. It's not far away from here, that has literally announced 2 weeks ago the first written spec repository, public repo, where you can go, look at a lot of different written specs, and be able to contribute your own as well. So this is something that I find really interesting. And written specs can go all the way from pure human language, or to have a combination of human language, templates, code samples. And I say, I want a code that looks like this to do this thing here. So there's all kinds of different outcomes. Now, the caveat here is that right now, all of these, again, non-deterministic by nature. LLMs are non-deterministic. So it happens a lot that you ask it to generate the same language, and it will create the same thing, or it will create 3 different things that do in 3 different ways. But this is a problem that we are also cracking right now, right? LLMs non-deterministic, but we have a way to make deterministic outcomes of non-deterministic things. So processes Our favorite thing, right? Everybody loves processes, yeah? I mean, you do Jira, Matt. Come on, you like processes. Let's be honest. So, all this process, right, of operation, development, all this development life cycle, right? We're not going to stop doing this. This will happen. It will just happen at faster speed, with more automation, more AI involved, right? So, in this, the important thing is that processes will still be regulated by Conway's Law. And we talk a lot about Conway Law here in London DevOps. But we don't say enough what Conway Law actually is. And I will read it, quote, any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So any app will look like the communication of the company and how the company is organized. So it goes back to processes, right? So the thing then is that silos will become more of a risk because the silo itself, the handover point will become more critical. We went from a handover point when we were doing waterfall of days, handing over from one team to the other, going through everything, to hours. In AI, might be minutes, we don't know. But handover points will become more and more and more critical. So we need proper interfaces, we need proper handover points that can be validated. So with this in mind, I said, we need to make sure that we have all the processes, all the handover points, all the things that we can deal with at speed. So rapid feedback loops, value stream mapping, which is one of my favorite tools, will become more and more important. Understand where the choke points of your process, where are the points where things get blocked, etc. If anything, you still will need to read these 3 books. And I normally don't recommend things, but these 3 are still really essential for any person that leads engineering teams, wants to build products, wants to build applications. And Team Topology is actually the new 2nd edition came out last week with some AI in it already. So it's important to get up to date on this. And finally, we go to tools. So favorite thing, right? All the vendors with all the tools and all the amazing things and all of it accelerating the infinity loop of DevOps and adding more and more things. So if I go into tools, what you can do right now, you can generate infrastructure as code using code assistants. It might not do the thing you want, but hey, it's fun. We have already agentic AIs that will resolve situations. So just today I was talking with Red Hat about Ansible and the automated events with AI that understand, rationalize what's happening and know how to escalate or resolve. That's already pretty good. I mean, I don't like waking up by night by some server going down because Apache is not running. If AI can do it for me, happy times. All the code generation and testing, I said code generation with written specs, you can do it now with prompts. You can generate all the tests with AI as well. You can look at the code, it's like generate me the test so this code passes these checks. Code migrations, one of the things that I hate most because it's always a pain, can be done fully with AI. There's this open source tool called OpenRewrite. You give it an old code, it will convert it directly to new code if you want, or it will actually tell you what the old code does. So you understand it, right? So no more snowflake code. You can go and understand what happened, what they were thinking, or what are the caveats of this piece of code. AI and monitoring, it's been here for a while, it's going to get better, right? There's going to be more AI. So monitoring will be smarter, will understand exactly what the problem is instead of telling you CPU going wrong here, memory going wrong there. It's like, actually the problem is this thing here. And incident management, right now AI, I said, can do some of the initial resolving of incident management. So I said, more quality sleep for most of us that are on call. What you will be able to do soon. You will be able to define your whole infrastructure through spec writing. So if you follow Adam Jacob, the guy that I love, not only because he's a metalhead,